Hello, my name is Todd. I'm going to be your logic tutor, and we're continuing on with our discussion of the rules of replacement. And right now we're talking about double negation. Now, this is not a rule that we really need in our system because we have our special notation, the opposite of. But not all systems have that, so for the sake of completeness, I'm just making you aware of this common rule of replacement, and here's how it comes into play. Suppose we have not P, then Q, not Q. Well, everybody's going to allow a modus tollens. Now, for our system, we can go straight to the P, but most systems will have you go to not P, and then by double negation you convert the not P into a P. So double negation lets you convert something like P into not P, or vice versa, not P into P. Okay, and as I said, the double negation is really not necessary for our system. Okay, transposition. Transposition allows us to swap the places of antecedent and consequent in a conditional. The only catch is, as you can see right here, we have to negate them. So let's suppose we have A, then B. Transposition lets us convert to such a statement to not B, then not A. Okay, and if we had something like A, then not Z, we can do transposition. The consequent becomes the antecedent, but we negate it, so not Z would become Z, and then the A would become A, not A. And that's all there is to transposition. Okay. Material implication. This is quite a handy rule of replacement. It lets us convert if-then statements into or statements and vice versa. So suppose we have something like A, then B, we can convert that into an or. How does it work? Well, the antecedent gets negated, so it would be not A. The then turns to an or, and the last item stays the same. So this would be a case of material implication. Wherever we have the top, we could convert it to the bottom, or vice versa. But let's suppose we start out with something like this, A or B, and we want to convert it to an or. The first disjoint changes its sign, so it becomes not A. The or becomes a then, and the B stays the same. That's how material implication works. And remember, our shapes represent variables, so we could have substituted in something, a large expression for B. Everything still works out the same. Okay, material equivalence. This is our only rule of replacement that deals with the material equivalence. So whenever you need a biconditional, you need to think about this rule. All right, so let's suppose that this equals something like Fred goes fishing if and only if Barney goes. Let's use this. Fred goes fishing if and only if B, Barney goes. Well, what does that mean? Well, it means if Fred goes fishing, then Barney goes, and if Barney goes, then Fred goes, which is just like this up here. So if we have this biconditional, we can convert it to this statement down here, or vice versa if we need to form a biconditional that we don't otherwise have. Now, Fred goes fishing if and only if Barney goes fishing could be expressed as if Fred goes, then Barney goes, and if Barney goes, Fred goes. But another way that we could express that idea is either Fred and Barney go fishing, or Fred doesn't go and neither does Barney. So when you have a biconditional, you may convert it into this first form, these two conditionals, or you may convert it into this disjunction down here. And of course, you can go the other way around. Okay, one more. We'll take a break after that. Exportation. Okay, suppose A and B, then Z. We can change this statement into something of an equivalent form, and what we would be doing is we'd be exporting this item out of the antecedent, okay? And it becomes A, then B, then Z. Does this make any sense? It sure does. Suppose that you're trying to gain entry into a nightclub, and we say, if you have a valid ID and the cover charge, then you get in. That's the same as saying, if you have a valid ID, then if you have the cover charge, then you can get in. So remember, you can go from an instance like this to an instance like that. And that's